Hi, everybody. Hey. So, really happy to see that many interested in software security, even though it's becoming a bit late in the day. I hope I can make you stay awake. I'm going to talk about the most dangerous software errors. There's a list of the top 25 vulnerabilities that's commonly occurring in all kinds of software. It's called CWE SANS, and I'm going to talk about what that list is and what you can use from that list to improve the software quality or security quality of your software. My name is Emil Kvarnhammar. I'm a security software engineer at TrueSec, and I'm also gonna, besides talking about the list, I'm also gonna show you a few demos, what this means in code and how easy it is to exploit security vulnerabilities. So I hope you find that interesting. So we believe that about security, it's really about knowing your enemy. And of course that also includes understanding who the enemy is, or who might be the enemy of your implementation, or who might be interested in attacking your implementation. Because if you know the enemy and understand your own environment and your own security level, then the situation is a lot better, and there's a better chance for you to survive attacks, or at least limit the damage made by an attack. So we need to address security from an attacker's perspective. And what's really the goal of an attack? It's typically, of course, ideally to execute code on the target system. That usually involves, like, depending on what type of implementation it is. If it's a web implementation, it could be potentially like a OS command injection. But it could also be like remote code execution caused by a buffer overflow vulnerability in native code. So, but an important goal is, of course, to be able to steal some data out of the system, like database dumps, credentials for all your users, or credentials for system-to-system communication. That's valuable information, of course, for an attacker. But before we dig into the list and talk about the vulnerabilities, I wanted to mention a few examples of cyber attacks or security vulnerabilities. I bet you haven't missed this, right? You heard about this. Yeah. And this led to that Chrysler recalled, like, I think it says 1.4 million, but I actually think it was 1.5 million cars because of this vulnerability. So what this was all about, it was that the infotainment system in the cars was accessible through a public IP address as long as you were on the same mobile carrier as the cars. There was a public IP address for the infotainment system, and the hackers or the security researchers that investigated this, they found a way to execute code on the infotainment system. Naturally, of course, it's not possible to control the car completely, like brakes and steering and everything, just from the infotainment system. But it turned out that the infotainment system was connected to a power unit, and the power unit was able to control steering and brakes and stuff. And they found another vulnerability, and they were actually able to reflash the software of that, the firmware of that power unit, so that they could gain complete control over the car. And that's usually the way attacks work. you exploit some kind of vulnerability in one part of the system to gain control over another part of the system that's even more valuable. And sometimes when we do penetration tests, or if real attackers perform attacks like that, they don't know what the end goal is. Not always, at least. Because you scan and perform attempts to attack other systems that are connected to the system that you already have control over. That leads us to think, what's the price of a security mistake in product development? Think about that from your product perspective. What does it mean if there is a vulnerability? If someone discovers a vulnerability in our product, what does that mean for our brand? How do we update our product? With a patch. Another example is the Xcode Ghost. How many of you heard about the Xcode Ghost? Not that many. So this all started in China with application developers for iOS. They were experiencing slow download times from the Apple service when they wanted to download the Xcode. It's like several gigabytes. And so an attacker found out a way to exploit that situation. So what they did, they repackaged the legitimate version of Xcode and included some extra fancy stuff in that. They included some code to inject code into the iOS applications built on that system. This resulted in hundreds of applications, actually some people claim thousands of applications published on App Store, passing the Apple App Store review undetected, with malicious code created by the Xcode Ghost. And what I'm trying to say here is that security is not only about the software you write, it's the environment you use to write it also. Highly affects the overall security of your product. There was actually a new, well, of course, Apple, when Apple got notified about this, they immediately withdrew these applications and started to contact the developers behind these infected applications to submit new ones compiled with a legit version of Xcode. But now there's actually a new version out, an improved version with the obfuscated version of this code that gets injected into the applications. It's actually quite primitive. It's just that, for instance, Apple, before they used to scan for the domain name string for the command and control center that this Xcode Ghost uses. So they scanned for that domain name in applications that were being submitted. Then they just changed in Xcode Ghost so that that domain name string is dynamically created, character by character. And all of a sudden, that's got undetected. So new applications were infected again. This is usually the way it works. Like you patch and you try to solve a security mistake. It's actually quite common that it's like a quick and dirty fix just to get the problem out of the way. But then attackers find new ways to exploit the similar vulnerability. Another example is Schneider Electric. It's an automation system for larger facilities, and it's called Structureware Building Expert Building Automation System, where credentials for the administrator of that system were sent in plain text over the network, which means that once an attacker has gotten access to those credentials sent in plain text, which I assure you they will, because there is a lot of tools available. I think Neil Merrigan showed a couple of examples yesterday at the Security Day. There is a lot of tools available to scan for credentials being sent in plain text. So once an attacker has access to those credentials, they have complete control over the automation system, like ventilation, possibly doors and things like that, lights. So we're not only going to talk about vulnerabilities and disasters like this, like the Xcode Ghost, for instance. We're going to talk about security benchmarks and what you can do to improve the security in your software. Maybe you heard about OWASP. Have you heard about, how many of you? Yeah, it's quite popular. So OWASP is quite common that people know about. It's a OWASP Top 10 is a list of common vulnerabilities in web applications. It's like injection, cross-site scripting, and cross-site request forgery, for instance. This is well known, but this is web applications mostly. So I wanted to share something with you that's not only about web applications, but also other software, like embedded and mobile applications, any type of software, basically. So there is another list from OWASP called OWASP IoT for the Internet of Things, but I think this is still somewhat limited. So we're going to talk about CWE SANS Top 25 instead. CWE stands for Common Weakness Enumeration, and this is not the same as CVE, like, which is basically an identifier for a known vulnerability in some kind of software. So the list is divided into 3 categories, and we're going to go through these categories in the presentation. And the categories are insecure interaction between components, it's risky resource management, and porous defenses. You'll see later what these categories contain. And in the list, for each CWE identifier, which means for each type of commonly occurring vulnerability, there's going to be technical details, there's going to be code examples, recommendations of detection methods, and some references where you can learn more about this type of vulnerability. So it's a really structured way of learning more about security attacks and learning how to fix it if you have these types of vulnerabilities in your software, which you might do. So the first category, insecure interaction between components. And the vulnerabilities in this list, we're going to see several demos of vulnerabilities from this list. We're going to look at SQL injection, command injection, cross-site scripting, upload a file with dangerous type. And but I really recommend that you read about the other vulnerabilities because I won't have time to demo all the 25. But this is very much web-focused, maybe except for OS command injection and SQL injection, which is sometimes occurring in other types of systems as well. So just to show you how the list is structured, so for example, with SQL injection, you'll see a summary of the vulnerability, like how the remediation cost, is it low or high? Is easier detection? Is it easy or hard? Attacker awareness. How many attackers know about this type of vulnerability? Attack frequency. How often is this being used by attackers? So it's not only about how common it is to find a SQL injection in code. It's also about how common this is being exploited. So in the description of SQL injection, you'll see exactly what this means, like SQL injection 101. So if you haven't seen this before, it's basically that you have some kind of SQL string being dynamically created based on some kind of user input or some kind of input, to be correct, that can be affected somehow. So it doesn't have to be user input. It could be input coming from a file or from a database field, for instance. And once that query is being created, it's going to be sent off to some kind of database framework, and the query is going to get executed, of course, and the results are going to be returned. In this case, the filter or the parameters is a username and an item name from some kind of text field, it seems. So to show that in a shorter version, it's basically select star from items where owner is the user in this scenario, and we only want to look up just this item name from the item name text box. But what an attacker would do to gain access to all the items would be something like passing or A equals A, which is always true. And that would mean that all the items are going to be returned in that table. This is the most simple example of a SQL injection. So this basically has the same meaning as no conditions at all. You might think that if there is a list like this, like CWE Sans, the top 25 most commonly occurring vulnerabilities, or the OWASP top 10, which is so obvious, then you might think that you're not going to find these types of vulnerabilities in 2015. But I bet you do. And a good example is wireless routers, that there are still quite many security vulnerabilities and extremely dangerous vulnerabilities in these types of devices. And I'm going to show you an example discovered this year. It's from a D-Link router. This is like a high-end router, expensive router. I think it's about $300. So it's not the one that, I mean, maybe that doesn't always mean that it's going to be more secure just because it's more expensive, but it's not like the cheapest one you could find. So I've shown the code now for some time. Has anyone spotted the problem? So the problem here is that we start at the top. The problem here is that the code executed on this wireless router for some kind of web service interface is going to extract a HTTP header called HTTP SOAP action. And it's going to use that SOAP action header. It's going to search that header and see, does it contain this purenetworks.com get device settings? And if it doesn't, then it's going to do an authentication check. That's mistake number one. So there is no authentication check if it finds this string. And then it's going to continue for doing some other reformatting. And finally, it's going to end up in Sprinf dynamically creating a shell command, which is going to be executed using the system function. So a good input from an attacker would be just to inject, we'll use this get device settings string to make sure that we don't have to authenticate. We'll include that, and then we'll add the quotation marks reboot, which is going to be interpreted as a command. This, I mean, are you surprised to see this? This is more or less the way it looks always in wireless routers, at least. The implementations are usually somewhat like this, but so there is, if you have implementations that are similar, where you need to perform some kind of system command, don't ever execute a command that the user has supplied, or where the user has supplied parts of that command. Never. Because that's going to end up like this, being exploited like this. And you'll be happy if they inject reboot. It's more likely to contain like a reverse shell so that it connects to back to the attacker. So I'm going to show you a few demos. We're going to start with SQL injection. And this is going to zoom in a little bit so that you can see. And this is just a dummy example. And the good thing about being a security consultant and doing presentations like this is that you don't have to make up examples. You'll get examples from performing reviews. So this is actually real examples, but just slightly modified to make it, not to make it obvious where this comes from. So we have a login method that takes a user and a password, and there is a validate login to validate if that user is allowed to access the system or not. So a SQL query is going to be created. And you'll see, I've run this once, you'll see failed invalid credentials. And let's just make sure that you can spot them. Yeah. So what we'll do is just, since this is just being concatenated and dynamically ending up as part of the SQL query, we just end the string parameter with the name, and we add or1 equals 1. And since there are going to be more conditions in the SQL query, we just terminate the string or comment out the rest of the SQL query. And we run that again, and let's see where we got authenticated. So that's a simple example of a SQL injection. And it actually, so what you should use is parameterized SQL instead, which most frameworks support. And this might actually fool people to think that this is some kind of parameterized SQL, but it's not. It's just a format string. So the next I'm going to show is command injection. Just switch. No, that was the wrong one. No, it's the right one. And shout out if you can't see, because I'm not looking there, I'm looking here. So this is a very stupid implementation of a base64 encoding method, where it's just taking the user-supplied input, and it's going to be included as part of a command being executed. And as you probably realize, you have full control over what you might want to, let's say that you want to print a file from the local file system, and we need a extra echo command to make the rest of the string happily executed. And let's see, the output at the bottom is, so this is the actual command being executed. And this is the output of cat. This is also something we find regularly. And we're going to look at a few two web vulnerabilities as well. So, cross-site scripting, I bet you heard about that. This is a simple web application, it's JSP. It's going to take whatever I'm supplying as input here in the text field. Like this is security, and I'm going to press save. That is going to be echoed here below. You get the point. But what if I write a script tag like alert document.cookie and that script tag? All of a sudden, I get a cookie string being printed here. So, of course, it's not a problem if I supply the input and it gets executed on my system as JavaScript. But as you might have spotted here, this is a get parameter in the URL, which means that it's easy to send this off to the victim and get the victim to execute this JavaScript instead. There are some security mechanisms built into the browsers to minimize the damage of cross-site scripting, but it could still be quite serious if you have still be very serious if you have vulnerabilities like this. Finally, we're going to look at unrestricted upload of file with dangerous type. Anyone who can think of a dangerous file type? Sorry? Any file is a dangerous file. That's a good point. So this is a web application. I mentioned that it's written in JSP. Anyone has an idea of a dangerous file type? Yeah, JSP, for instance. Sorry? PHP, maybe, if this web, depending on what type of web server I'm running. So I think you definitely understood the issue here. So that was a simple file upload. I just uploaded a PNG file here. And I click upload more, because I want to try uploading a JSP file. So this is a web shell, basically a web page just taking whatever input I'm supplying and executing that as a shell command. So I'm going to try uploading that instead. And if I press view your file, this is my web shell, and I'm going to root. Oh. This is because I'm running in Docker, and normally, well, this was just a quick and dirty setup of a Tomcat server. Normally, the Tomcat server would probably not run as root. I hope it wouldn't. So, you get the point. It's quite useful for an attacker, just have a web window to execute an arbitrary command. And this is actually a really tricky problem. It's complex to implement a bulletproof file upload functionality. So the next category is risky resource management. And now you'll probably recognize, if you're C developers or C++ developers, if you're doing embedded stuff, then you'll probably recognize a lot of these, like classic buffer overflow or uncontrolled format string, incorrect calculation of buffer sizes. Some of these could potentially lead to remote code execution on the target system. And of course, there are some mechanisms in modern operating systems that should protect against or make it harder to exploit vulnerabilities like that, like ASLR, for instance, or data execution prevention. But still, it's possible to circumvent that kind of protection in most cases. So we're going to look at a buffer overflow, and it's not the common type of buffer overflow, so I hope you find that interesting. Excuse me. And we're back to a similar scenario that I showed before. We have the login method, and we still have some kind of login context, keeping the user and the password. And we have a validate login method, which is basically going to search. This is some C++ if you haven't seen this. So it's going to search through the users list and see, can we find these credentials that the user supplied? And if we did, then we're going to set authenticated to true. And authenticated is going to be false by default. So if I, as an attacker, has gotten access to this code somehow, either the source code or the binary, and we do some reverse engineering to understand how this software works, then I want to look closer into how login context is implemented. Login context takes the user and the password to the constructor, and it's going to create a credentials object or a user info object, named credentials. And after that, we have the authenticated flag. And authenticated, as I said, is false by default. So this user info object is where the actual vulnerability is. We have a buffer of 32 characters containing the password hash. So in this users list that we're searching through, then it's going to be the real password hash, of course. And in the supplied user info from the login method, it's going to be the password hash of the supplied password. And the same goes for the name. And you probably spot the issue here that if we have more characters than 32 in the name, then we have a huge problem, because that's going to get overwritten. Or actually, the reason behind that is here, because the username is going to be copied using strcpy, string copy, into name without checking any limitations. So going back to user info and login context, what would be interesting would be if we could set authenticated to true. That would be fun. And we could probably do that by overwriting the user infrastructure. So let's try and see if that works. So we have 32 characters. Well, we should run it once with a guessed password. So the real password is secret, and I don't know that password, so here's my guess. And running once says failed invalid credentials. So let's make a new attempt. And if we don't have access to the code, we could just randomly try this out and see what the limits are. So now we have 30, and we want to have 1, 2, and 3. That's 33. That should be right. And this is going to be treated as non-zero. It's going to be true. Let's see if that works. Run. Failed? No. Let's make it one more. That doesn't work. Oops. What did I do wrong? we have 32 and... Did I mess this up? Failed emailing credentials. Let me count this one more time. 1, 2, 3. This should work. Yeah. I wonder what went wrong there. So we're overflowing the buffer containing the username, and since we just have something being overwritten into the Boolean authenticated that's non-zero, then of course that's going to be interpreted as a true condition. So this is a buffer overflow without like executing arbitrary code. It's just affecting the data structures in the implementation. An easy way to exploit buffer overflows. So, let's see if I can get my remote working. No. The last and final category is porous defenses. And this is where it's getting a bit more soft and vague. Because now it's not about like, you should not use this function like this. It's more like how you've implemented the logic of authorization or authentication. How do you authenticate the users in your system, in each part of the system? How do you make sure that this user is authorized to perform this type of operation that's being done right now? And vulnerabilities like this could typically be utilized if you have a valid session. Let's say if it's in a web, some kind of web system. If you have a valid session as a regular user, it's quite common that you can exploit vulnerabilities like this to become an admin user. Just by visiting some kind of admin page that doesn't perform the authorization check, because it didn't expect regular users to know the URL. I'm going to make a final demo of the vulnerability at the bottom, use of a one-way hash without a salt. And that's here. We have Alice and Bob again, and this is some kind of register method where the users gets registered, and you'll see a printout of the username and the password hash. So if we run that, we'll see that the hash is the same for both these users. And this is of course because it's secret for both these users. And this becomes a problem because if an attacker gets access to a credentials database, for instance, database dump, then if it's as simple as just Googling, of course that depends on what the password is. But if it's less complex passwords, then you'll find the hash or the original text for this hash. You'll find it on Google. So you'll see, this is the SHA-2 hash of the string secret. Thank you. So, sorry, I should be in the development environment. So how do we fix this? We fix it by adding a randomized byte string as a salt. And of course, we need to keep that randomized string as well. And you'll see now this is the new hash appended with the salt. And you'll see that the hash is different for these users. So, finally, I'm running out of time, so finally I wanted to make a few recommendations at least. I do recommend that you start doing code reviews and threat modeling if you haven't done so already, and that you measure against the CWE SANS top 25 list. If it's a simple web application, then OWASP top 10 might do. But start measuring. If you have like 8 of them today, fix them. At least fix some of them so that you have 6 the next time you measure, or 4. And finally, it's becoming 0, hopefully. And keep your development machines safe and clean, because that's extremely important. It's going to be more important in the future. We're going to see, I'm pretty sure we're going to see more attacks similar to what we've seen with Xcode Ghost. And the next time it's probably going to affect Java developers or .NET developers, who knows. So make sure that you encrypt your machines, be careful what you install, and things like that. Be careful what types of third-party dependencies that you're including. Some references, if you want to look at the list, CWE SANS, it's at sans.org. And if you're interested in the OWASP lists, they're at owasp.org. And I won't have much time for questions, but thank you very much for listening, and feel free to catch me after the presentation if you have any questions. Thank you.